Second to last page. Continuation, guys, from yesterday. Did that. We did this, right? The in conclusion, we got all that?
Yeah.
Sweet. All right. I think we did. All of a sudden we started adding, we put a C at the end of our quadratic, right?
Yeah.
But first, we did the parent function, which we know to be 4, 1, 0, 1, 4. -2, 4. -1, 1. The origin 0, 0. This is the parent function. And 2, 4. Okay, did you guys end up graphing this one?
Yeah.
Go to your next page and see if we graph it.
Yeah, we put a star where we stopped.
Yeah.
Right, but did you guys graph it on that next page?
Yeah.
we
All right.
grabbed one. We just didn't graph
So here it is. 1, 3, 5. 1, 3, 5. Look how I graphed that so quick. Using the 1, 3, 5 ratio. Make a curve. Graph your parabola. Okay, I kind of missed that one point, but that's okay. All right, now go back a page. Let's do one where C is new. We started this, agree?
Yeah.
All right, so what did we say? -2 squared minus 2. What was y then?
2.
2. -1 squared minus 2. -1.
-2.
0 squared minus 2 is -2. Fill in the rest of the chart, guys, if you haven't done so already. Y equals 1 squared minus 2, which is -1. Y equals 2 squared minus 2, which is 2. So that's the points. 2, 2. -1, -1. Excuse me, -2, -2. 0, -2. 1, -1. 2, 2. All right, go to that graph and graph those points. Oh, before you do that, guys, wider or skinnier?
The same.
The same. Is A changed at all?
No. It only stayed.
Look, guys, it was y. The second one is y equals x squared minus 2. The parent function is y equals x squared. That's the red one. Okay? What is the value of A changed at all? No. This next one's going to be the same size. It's just going to move. -2, 2. -1, 1. 0, -2. 1, -1. And 2, -2. And there's always one kid that's like, that's wider than the first one. Kind of looks like it is. But guys, it's the same thing as the red. It just shifted down 2 units. Okay? It's the same thing as the red. It just shifted down 2 units.
Wait, that's not 2.
Yeah, how is it 2?
Where's 2 -2's not on the graph? Oh, I think it's supposed to be 2 +2. Right? Was 2 +2?
Yeah, it is.
My bad. I wrote it wrong. 2, 2, which I think is right here.
Yeah. Pretty much.
Stop.
All right. Go back and let's try one where C is a positive value.
Okay.
C is a positive
It's
value.
on the back
That's the opposite of the last one.
Right? Plug your values in. Watch what happens. What's y when x is -2, guys? 7. -2, 7. Make sure you're using parentheses, guys, around your negative values when you plug them in for x. You guys get 4?
You better restore.
Did you guys get 3?
What are in your store?
Back to 4. And I bet this one goes back to 7.
Maybe not.
Why would you think maybe not? Okay?
You were right.
So your y column, guys, make sure you have this y column correct in your notes. 7, 4, 3, 4, 7. Notice that 1, 3, 1, 3, and I bet the next, if we did 3, I bet it would be at 11. 1, 3, 4. Or no, it would be at 12. Excuse me. 1, 3, 5. Okay, graph that one.
Whoa.
Negative 2, 7. Negative 1. What was it? Negative 1.
4.
Thank you. 0, 3. 1, 4. 2, 7. Graph those. Negative 2, 7. Negative 1, 4. 0, 3. 1, 4.
Making the triple deer.
2,
7.
7.
That's 6.
Skinnier or fatter?
Doesn't it sort of look like a deer? The arrows are antlers and then the top points are eyes.
Okay. So it was the same, guys. It just moved how many units up?
Oh my god, it looks like a face.
But guys, don't worry about what it looks like. Seriously. You're bothering me. It moved 3 units. The blue one moved 3 units up. Plus 3. What did the green one do?
Move down to.
It moved it down 2. Okay.
Oh yeah, it does.
Now, the value. Let's put all this stuff together now. See if we can do this. The value C is called the vertical shift. Vertically goes up and down. So the C changes the parabola vertically. If C is greater than 0, what kind of number is greater than 0?
Bigger.
Positive.
Positive. If C is positive, the graph is shifted C units
Up.
up. And whatever that value of C is, that's how many units it's going to go up. If C is less than 0, the graph is shifted C units down.
Oh, so like instead of the origin being -30,
Right.
and then
If its C is minus 3,
and then you do the 1, 3, 5 to get. Oh.
so now,
When you do 1,
we're-
3, 5.
what's that?
When you do 1, 3, 5, you move it over.
No. Oh, you go from the point that you graphed, you go from that point. You don't go back to the origin and start over. Once we do an example, you'll see what I mean by there, Nico. But I think I'm answering your question, I think. So, let's try to put all this stuff together. Okay? We're not going to use a table. Do not graph your parabolas using the table. You're going to use your up, down. Question? Can you guys all answer that by looking at a quadratic? Yes or no?
Yeah.
Yeah.
You're going to use your vertex is at 0, C.
That's easy.
That's what you just learned. And then you're going to use the 1, 3, 5 ratio.
Wait, is C?
All right, let's do this. Once you do this several times, guys, you'll be amazed at how fast you get a graph. All right, here we go. Y equals 2x squared minus 3. Up or down?
Up.
A is positive, goes up. Where is the vertex?
-3.
Well, you got to give it to me as a point.
0, negative, or -3. Yeah, 0, -3.
0, -3. Notice 0, 3, or excuse me, 0, C is what we learned where our
Wait,
vertex is.
is the vertex always going to be on the y-axis as long as there's no b?
Yes. That's the key. As long as the b is 0, the vertex is always
Are we
on.
doing parabolas with these?
Oh yeah, start tomorrow.
Oh.
Where would the B be?
I'm not going to tell you. We're going to figure that out tomorrow. Great question.
Heaven.
Yeah, I knew it.
That was
me.
Heaven was one thing.
All right, and then, guys, here's what I want you guys to do. Every day, 1, 3, 5, and put an arrow pointing to that. And then when we have a coefficient in front of our x squared, What do we do with our 1, 3, and 5 to get our new rate, to get our new pattern?
Multiply
Multiply by what?
A by 1 and by.
Yeah, you multiply by whatever that A is. So I always put a little times 2 above the arrows. So it's going to be 2, 6, and 10 because the A really affects the pattern there.
So whatever the A is, you just multiply by that.
By 1, 3, 5. Okay, so our 0, negative 3 is our vertex. We got that. We know it opens upward, so I'm going to go up with this. I'm going to go up. The first ratio is 2, then 6, then 10. I always start on the right-hand side, but you totally can start on the left-hand side if you want. So I'm going to go up 2, 1, 2, over 1. It's always over 1. Over to the right one. Then I'm going to go up 6. 1, 2, 3, 4, 6. And notice I went up 6 from that first point that I graphed. Ooh, I meant to ask this question. Gosh darn it. Skinny or wide?
Well, then what?
Then the great question. Then skinny or wide compared to?
What?
That's what Alex asked. That's a great question. When I say skinny or wide, what am I comparing it to?
Oh,
X
What?
squared.
The parent function. So
Parent function is x squared.
y equals x squared. Just the normal y equals x squared origin 1, 3, 5
it's
up.
gonna be wider.
No,
Skinny.
it's gonna be skinny.
Oh wait.
How
What's
I know it's
C?
up
Is C the
also.
origin?
No. C is negative 3. 2x squared minus 3. What's C?
Negative 3.
Negative 3.
But wait.
Hold on now. Come on, Cuban, let's get this straightened out.
Oh, and then. Oh, you go up 1 and then up 3.
But no, we're going to go up 2 and then up 6.
I know, but for the parent.
Parent,
function.
yes, 1, 3, 5 is the ratio for the.
Ah.
So I'm going to go up 2 over 1. And then from that point, I'm going to go 6 more. 1, 2, 3, 4, 5, 6 over 1. And from there, I'm going to go up 10 more. Do I have space to do that?
You go down
Not
and
really.
left.
I'm going to go 1, 2. No, do not do that. You just ruined everything.
Can you go down 10 and over 1?
No. It's always up and
I
over.
just said
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1. I'm just eyeballing it. You don't really have to do that. If it goes way off the graph, guys, you're good with just 2. But now you got to do the same thing on the other side, that symmetrical aspect.
that.
So go back to the origin. I'm going to go up 2. Ooh, look at
It's actually
that.
really skinny.
Then I'm going to go up 6.
Yeah, it's actually.
1. Then I'm going to go up 10.
Okay.
Oh, I forgot to go over 1 there. Okay?
You
And
have
now, draw a curve. And it's hard to do that because it's so skinny. It's not a V, it's a parabola. Right?
That in my
And
head.
now we see
Right.
a husband and wife.
So, guys, that's how you graph. Okay? Here's what you guys got to think about. Which way it goes, up or down, name the vertex, 1, 3, 5 work. Go ahead, Olson.
If A is positive, it goes up. If A is negative, it goes down.
Yes,
Okay.
every time.
And then how do you find the vertex again? It's just 0,
Where's the vertex at?
0, C.
Right.
So it's 0, whatever C is.
Yes. On the parent function. What's C?
0.
0, 0. The origin. Parent function is at the origin.
Oh.
Right? You guys can do this
That's
stuff.
what we did yesterday.
Right. Go ahead, Aaron. Question. Guys, you ask the greatest questions. You guys ask the greatest questions.
Alex.
I'm a little confused on how you find the points
Okay.
for the graph.
Do you agree that the pattern's 1, 3, 5? Do you agree that the coefficient of x squared is 2, so we need to multiply 1, 3, 5 by 2? So we're going to go 1, 3, 5. You're going to write this down. 1, 3, 5. I always put an arrow. You can do whatever. And it's really 2, 6, 10. Because the 2 has changed our parent function to be really skinny. So from the origin, I'm going to go up 2, and it's always over 1. And then I'm going to go up over 1. And then I'm going to,
Okay.
and then I'm going to do what?
Up 10 over 1.
You do the same thing.
Do you have to do the time normally?
If it goes way off your graph like this, no. But it would be, no, you don't have to do it.
You just draw your lines.
Aaron, did that answer your question?
Yeah.
If, remember, it's all, this is the ratio. Guys, this work. This is so much nicer than making an XY table.
Yeah, it
Okay? Try the next one. Go. You got it right there.
At the board,
I'll do it on the board.
That's okay.
I'll call Kevin up.
Yeah, we can do it together.
Like a parabola.
I don't have a graph for this. So y equals negative 3x squared plus 1. Negative 3x squared plus 1. So now, tell me, before you start doing anything, tell me something you know about this.
That you gotta do it 135. It's
Okay.
negative 135.
Oh,
Good
yeah.
word.
It's,
And-
135 by negative 3.
Okay.
I got the up and down.
Negative 3. The negative sign really doesn't matter, guys. But I'm going to put them there because that's what Sean said to do.
Because you know it's going down.
You know what's, yeah, that's my next question. What else do you know about this one? Is it up or down?
Down.
Is it skinny or wide?
Oh, yeah.
Compared to the
Skinny,
parent. it's
skinnier
wide.
than the other one.
Compared to the parent function.
Oh, it's skinny because it's 3.
Skinny. Is it skinnier or wider than the first one you guys did?
Wider.
It's even skinnier.
Or skinny, yeah. But I'm confused. It's negative 3.
You could have just multiplied by 3. That's fine.
But if it's negative 3,
It's
is that
the
small?
absolute value. It's the
Oh, it's
absolute
absolute
value.
You
value?
can think about absolute value. Yeah. I put because you're going down. When you do the 135, you're going down, so you can have negatives. If you don't have negatives, as long as you still know you're going down.
Absolute value of
No.
what?
No,
Of-
you meant like why?
Of the A.
Why would it be smaller if it? Why?
It's negative 3. Is that smaller than 0?
It's the absolute value. When you
That's
talk
what
about
I
the
thought.
thickness. Yeah. All right. Somebody say something intelligent about the vertex.
The farther away.
Give it
from
as a
zero-
point.
0, count.
All right, so you got all the important things now, guys. We know that it's really skinny. We know that it goes down. We know the vertex is at 0, 1, and then the pattern is 3, 9, 15.
Negative
You want-
3 and
Whatever, dude. You know what I mean. Graph it. Go.
I thought he's always so.
Yeah, I know.
What about
You guys are like
negatives?
showing.
It's like,
1, 2.
it's like what's the answer? 3. There's no 3.
I actually went 3 units off the graph, even on my second point. 3, 1.
Do we have to do any tables on our homework?
Oh,
Nope, you're going to do them all this way.
So we use graph paper.
How many people got a skinnier graph even than the first one?
Make our own graph.
Notice, you had to go 3 units off the graph to get down to,
Oh, yeah, homework.
Well-
we do our
Don't
own
do the
graphs.
really 4 units off. No. Oh, yeah. I didn't go down 3 there. I only went down 2.
Those are
It should be right here.
Ooh, same with me. Oh no, because you're starting at over 1.
Yeah, but that.
Did you say
You
it's
start up
starting?
here.
Oh, yeah, you're right. You're right. I was right.
You're right.
I was right. Nice catch, Olson.
What?
You're at a negative 2 because I started at 1. So 3 units down would be at negative 2. So, can you guys do this stuff? You will need your notes. When fractions come into play,
Oh.
watch this. If you have a half x squared, 135, watch what happens. A half, 3 halves, 5 halves.
That's what we want to
You gotta go down a half and over 1. Can you guys all graph a half and eyeball it? Don't. Then you gotta go down 1.5 more. So you go down 1.5 and over 1. So you would actually be back on a whole nice integer if you went down 1.5 from a half. Think about that. Okay? And notice it is getting wide there. Alright. Somebody raise your hand and guess how many problems you guys have for homework you have to do like that.
6.
12.
Less.
12. 12.
12.
Oh, I was close. I guess 14.
Oh, it's on a
I guess
worksheet.
6. You said less. I said like 4.
John just told me.
I got excited. I was like, yes, 4.